With confirmatory factor analysis, you assume that your measured variables are manifestations of a specific number of factors. In the simplest case, let's say you assume there is one factor, measured with 5 variables. The factor is an unobserved variable. We assume the factor caused the observed variables to some varying degree and with some error. Measurement invariance is an approach that seeks to account for the existence of subgroups in the population you are trying to measure. It achieves this by extending the CFA model by allowing groups to have different means for one or more of the measured variables. Notice that the loadings, intercepts, and errors of this multi-group model all now have subscripts of j to denote that they can vary between j number of groups. Observations from the same group have the same values for these parameters, and they differ from observations from different groups. Now that these things are allowed to vary between groups, it is possible to actually test if they don't vary between groups. When testing measurement invariance, we restrict these properties in steps. Assuming you tested configural invariance, the loadings are held constant to test for metric invariance. The intercepts are additionally held constant to test for scalar invariance, and the variance-covariance matrix of the residuals is additionally held constant for full uniqueness. The type of invariance you would need to see when developing a new scale depends on the way the scale will ultimately be used. If you want to use the scale with its mean levels, which is almost always the case, then you must achieve at least scalar invariance. That is, the loadings and the intercepts must be the same for all subgroups of your population for you to be able to compare mean values. Metric invariance is good enough for some uses. If you achieve metric invariance, then your scale can be used as a metric in a dashboard in terms of comparing bivariate relationships with other variables. Thus, you could use this metric in some dashboard, but remember, this dashboard would not be a dashboard of individual metrics, but rather a dashboard of second-order relationships. The unstandardized covariance of your scale is still meaningful, the way it dances with other things, but never where it lands. The scale does not hold meaning when used in this heterogeneous population in any univariate sense. Then the question would be, what would be your practical use for such a dashboard? That is, can you think of a bivariate relationship that you would want to know if it were getting stronger or weaker? Can you think of a bivariate relationship, a relationship between two variables, that should trigger action in policymakers if the bivariate relationship got sufficiently strong or weak? These are very difficult questions, but the answer to them is an argument for the sufficiency of metric invariance. So let's think about these things while focusing on your breath, the visuals, the sounds, or some combination of these things. Thank you for joining me for this meditation.